Stop building stateful hacks. If you're still thinking MCP sessions are required, this is the part you need to see. Today, we're refactoring real MCP code to go completely stateless. No fluff, just real code, live demo. Let's dive in.
MCP just went stateless. Here's the actual problem that caused and the actual code that fixes it. Old model. A client calls create basket. The server generates a session ID, and that session lives on whichever instance created it. Instance A, say. Now put a load balancer in front of that. The very next call, add item, round robins to instance B. Instance B has never heard of this session. The request just fails. That's not a bug. That's what session pinning does by design, and it's the exact problem this spec update was written to solve.
New model. Create basket doesn't generate a session. It mints a handle, BSK A1B2, and hands it straight back to the client. Every call after that carries the handle as a plain argument. Round robin the same request to instance A or instance B. Doesn't matter. Both can look up that handle the same way. No coordination between instances required.
One more thing changed that's worth a quick look, even though it's not really about sessions. Before, if a gateway or load balancer wanted to know what kind of request this was, a tool call, which tool, it had to fully parse the JSON RPC body to find out. Watch what happens to method and name. Same JSON body as before, at the bottom, but now that same information also gets copied up into two new HTTP headers, MCP-method and MCP-name. Nothing was removed from the body, but now a gateway can route or meter this request just by reading two headers without ever opening the JSON.
So 4 things changed under the hood. The initialize and initialized handshake is gone. The MECP session ID header is gone. Any request can now land on any server instance. No sticky routing required. And method and tool name are now exposed as headers, so gateways don't need to parse JSON to route. If you want the full architecture, the diagrams, the IDJAG token flow, the deprecation timeline, what you actually need to migrate, that's the video linked in the description. This video is the hands-on follow-up, the real code, before and after, for both the server and the client. Now let's see that fix in actual code, starting with the server. That's where almost everything happens.
Here's the stateful server. The constructor just takes a name. Nothing session-related here at all. That's worth remembering for later. This dictionary holds every basket, keyed by session ID. Create basket takes a context object, CTX. That's how it reaches the session, implicitly. It pulls the session ID off CTX, creates a basket keyed to that session, and returns just a status message. Add item takes the same CTX parameter, every call. Same lookup pattern, repeated. Pull the session, find the basket, fail if it's not there. And down here, transport equals HTTP. No stateless HTTP flag. Sessions are on by default. This is the exact setup that broke on slide 2.
Now the stateless version. And here's the thing worth pausing on. This constructor line is exactly the same as before. Nothing changes here. The dictionary is keyed by an explicit basket ID now, plus a TTL constant, since expiry has to be handled on purpose. Create basket takes no parameters, no CTX, no implicit anything. It mints its own handle and hands it straight back to the caller. This is the handle you saw traveling across instances on slide 3. Basket ID is just a normal string argument now. The lookup uses that argument directly, plus an expiry check. And here's the actual toggle, the one line that matters. Stateless HTTP equals true on the run call, not on the constructor. That's the entire server level change.
Constructor, side by side, identical. This surprised me too when I first got this wrong and had to fix it. The state store, session keyed, becomes handle keyed, plus a TTL. Create basket, an implicit session, becomes a minted handle, returned to the caller. Add item, CTX becomes basket ID, a plain argument. And the run call. This is genuinely the only line where the toggle lives. Everything else is the application logic adapting around it. That's the whole server diff. 4 lines of application logic change to support explicit handles, and 1 line, stateless _HTTP equals true on run, is the actual switch. Now, the client. This is the short part.
Here's the client's imports. Notice, there's no stateless anything here. There's no import for it, because there's nothing to import. The client just takes a URL. It has no idea and no way to know whether the server on the other end is stateful or stateless. Same async with connection pattern, either way. Same call to mint a handle. Same call to pass it back. Nothing about this code changes based on the server's mode.
Point this exact client at a stateful server or a stateless one. This is the same code, byte for byte. No special import for stateless mode, no flag to set, nothing. Here's why. Stateless HTTP lives entirely on the server's run call. It's a transport configuration, not something the client negotiates or declares. The client was never in the business of managing the session in the first place. It just echoed back whatever the server handed it. Take the session away, and the client has one less thing to echo. Everything else about how it calls a tool is untouched. So here's the full picture. The server picks up one new runtime flag and a handle-based pattern in its application logic. The client picks up nothing. It's the same code, unmodified, talking to a completely different kind of server underneath.
Everything in this video so far has been code and diagrams. Here's the same thing actually running. But before I touch anything, let's look at the code underneath it. Same cart tool, 2 ways. The stateful version pins everything to a session ID a load balancer can't route consistently. The stateless version mints a handle instead. Create basket hands it back. Add item takes it as a plain argument. And the only thing that changes on the run call is one flag. Stateless HTTP equals true. This is the shared agent loop, the exact same code path the terminal script and this browser UI both call. It discovers the MCP tools, converts them to the schema an LLM expects, and lets the model decide what to call. 2 backends wired in, a local Llama model or a hosted free tier model on OpenRouter. All right, that's the code. Let's actually run it.
This page talks to a real MCP client, which talks to the real stateless server. No session, nothing faked. First call, list the tools. Create a basket. No session ID anywhere in this request. The server hands back a handle, and that's the only thing tying this basket to me. Add an item, passing that handle straight back as an argument. No cookie, no header doing this for me behind the scenes. I'm carrying the state myself. Watch what happens if I actually refresh. The page forgets everything, but the basket itself is still sitting on the server because it was never tied to this browser cap in the first place. That's the whole point. This time, let's point it at OpenRouter, a hosted free tier model, so there's no local warm-up to wait on.
And this part isn't me clicking buttons. It's a real LLM deciding what to call. Same server, same 2 tools, but this time the model reads the tool descriptions and drives the whole sequence itself. It figures out on its own that it needs a basket before it can add anything to it. There's the create call, and now it's adding the item. And there's the final answer. Same basket, same item, entirely the model's own doing. Everything you just watched, both server files, the client, this agent script, this whole demo page, is linked in the description so you can run it yourself. Subscribe if this saved you a weekend of reading spec diffs.